Okay, now members, the next number I'm going to do number 10 for paper 1 and also do number 10 for paper 2 because the numbers were not fitting. So this one was coming from there, this is now for paper 1, the other one is for paper 2, number 10. So this one says town B is 44 kilometers south of A. Town C is 30 west of B. Find the bearing of A from C. Here the word from is so important. Now for you can turn the scale, then you can use your own scale, but the better scale was in our solution, you convert these ones to centimeters by saying, now let me use a scale of 10-10. It was easier to use 10-10. So these ones, to convert them to centimeters, I'll be having 4.4 centimeters using the scale of maybe 1 centimeter represent 10 kilometers. So 1 centimeter scale of 1 centimeter represent 10 kilometers. So those will be the centimeters there. Then here I'll be having, which will be 3.3 centimeters. Now to plot that one, you come and see that now they're telling me that town B, the word you see is south of A. So it means that we're starting from the word A. So town B is 44 kilometers south of A. Now I'm going to start by drawing my A there. So this is going to be my A here. This is my A. This one you use either graph or you can use a set square. So this one is now my A. This one is 44, which is now on our conversions is going to be 4.4 centimeters. So now I come here and I measure my 4.4 centimeters. To me, my 4.4 centimeters are here. Then I measure off those 4.4 centimeters. And where those centimeters stop, that's where I'm going to put now. I get my ruler, and this will be my town B. This is going to be my town B. So this one is 4.4 centimeters. Then they are telling me that town C is 33 kilometers west of B. This is east, this is west. So from here, I measure now 3.3 centimeters. So 3.3 centimeters from there. You can use your set square to measure the 3.3 centimeters. Mine are here. West. Is this my west of A? Where they stop is where I draw my compass. If you use a graph, it's going to be very accurate. But even if you use a set square, the answers, and you are so accurate, the answer is going to be the same. This is 3.3 centimeters. Now this is going to be my town C. Now the bearing of A from C. So meaning we are starting from here, from C. So now I connect, I connect those two, F from C. So my ruler is somehow short, but I will manage to do a right thing. So from there, this is always use longer rulers. This one is for us people who, okay. Now from there, they want the bearing of A from C. So I just measure off this. Remember, this is my north. This is my north here. This is my north. So from here, you just get your protractor and then you measure off that. So if I get my protractor here, this is now my protractor. So I measure off, I put it here. So me, I'm getting something like, you remember that we always, in bearing, our protractor should be like this. So sorry for that, our protractor should always be like this. And if I'm to measure mine here, I'm get something like 38. Yeah, so now the bearing, our bearing is going to be, remember, we said bearing we give to 3 digits is 0, 38, of course, degrees like that. So that's how you can get 38, 39, those who are accurate, but that is going to be close to that. So now next number, the number comes from similarity. It says in the figure below, PT is that, TR is that, ST is parallel to R. The area of the triangle PQR is 75. Actually, the area of the triangle PST, so it's our PST, so that PST is similar to PQR, and this one is smaller than the big one. So there is similarity. We know that if you want to get the area, we use the area scale factor. You know that our area scale factor will be equal to area of triangle, the big PQR, over area of the small triangle, which is PST. But you know that we have two sides, the one for PR and one for PTS. How? Because if I have only one area scale factor, I need the area scale factor. So there I'm going to use the relationship between the area scale factor and linear scale factor. You know, all know that the area scale factor is equal to linear scale factor, the whole squared. Now, can I get the linear scale factor? From here, you can say I can get my linear scale factor. My linear scale factor is going to be the big length, which will be PR, over the small one, which is PT. And this one will give us the big one is 110 over the small one, which is 8. How am I getting 10? I'm getting 8 plus 2 to get 10. Okay, so that's what we have. So now I can substitute here. So here my area scale factor will be equal to now linear scale factor, which is 10 over 8, the whole squared. But now I know that this one is going to be, but my area scale factor I said I am going to get the area of PQR over area PST. This will give me 100 over 64. But I have the area of this big one, PQR. They gave me 75, so I have 75 over area of PST will be equal to over 64. And so now my area of PST, they are just simplifying that thing. You will get you'll get 48 centimeters squared. So that's why we had to do that number with ease. So as simple as that. So that's it, members. That's how we handle those two. Don't forget to subscribe to the channel. I wish you well.